Hey guys, I wanted to give you a little bit of a kickstart on the productivity problem since you are online and you might want be a little bit confused if you haven't used Excel before. So here's the assignment that I've downloaded. This is your assignment, and you're basically just going to go through and answer the questions where we have highlights. I want to note first these hints given up here just to the right of your data. And it says, you're using Excel formulas to calculate your answers. That's not an option, that's an imperative. If you do the numbers offline and then you just type them in, that's zero credit, absolutely zero. You get nothing for that because the input that we've had from industry in the area, and it's what we know to be true, is that Excel skills are valued by them. So when you come out of a supply chain management program, they're expecting you to know how to use Excel productively. So there are just a few little hints here at the beginning if you're not familiar with Excel on how to use it. So let's just dive in. So we have data up in here, in these cells up here, and what do we do with it? So it says compute the single factor productivity for labor for the parent's operations in units per hour. So a single factor productivity, if you'll look in your book, we'll talk about maybe partial productivity versus total productivity. A single factor is often used. So if I'm managing labor, then that's the only thing I have control over, and so I'll be measured on productivity per labor hour. If I'm the maintenance department and I'm responsible for the availability of the equipment, then quite often I'll be measured on the productivity of the equipment. So there'd be outputs, total outputs divided by equipment hours or equipment dollars. So in every case, productivity is outputs, and we're talking about the total outputs divided by some inputs or all the inputs. If it's a single factor, we're only looking at one input. So it's going to be, it's going to be the units produced. That's not the same as sales. Sales could be taken from inventory. We're looking at outputs, and think of the manufacturing floor. What do they produce? So the outputs, and in this case, we're looking for, and that's in units, and this is units produced, and we're dividing that by labor hours. So here's the labor hours. So it'll be this cell, and in Excel, if you're not familiar with it at all, it's the cells are designated by the column that they're in and the row. So this is C7, column, row, C7. And actually, if we go down here into our cell, and first of all, we have to tell Excel, okay, this is a formula, and we type in the equal sign. And so at that point, Excel knows, okay, this is a formula. And then I can either type in the cell, which happens to be C7. If I do type it in, you can see that Excel highlights it. And then I put my division sign, the slash, and then I can type in the cell where the inputs are, and it highlights that one. I can do that, and Excel shows you the formulas. Or I could just as easily, in this case, just click on the cell, and Excel will write it in for me. It highlights it and writes it in, and then put my slash, and then click on the other cell, and it's there. So that calculates for me. What that does is take 1,400,000 and divide it by 40,000, and that's 35 labor units produced for every labor hour. The 1B is just looking at the same formula over in the subsidiary column. So we have a parent, which is domestic, and we have a subsidiary, which is in some less developed country, which we read is cheaper. And so we go into this cell. Again, we tell Excel that it's a formula. Say, hey Excel, it's a formula. And I highlight, and I'm done. The difference between this formula, and this formula is just the column. We moved this formula over to column D from column C. And then you're to interpret your findings and basically tell me, in this case, that the parent operation had a higher productivity than the subsidiary. Okay. Now, we could also look at labor productivity on units per dollar. We looked at units per labor hour, but we could also look at units per dollar. Now, a little bit more complicated process, but we're given a hint actually over here on how to do this. We have labor hours and we have a labor rate, but we don't have labor dollars. And so to get the labor dollars, we're going to be multiplying the number of hours times the hourly rate. So only slightly more complicated. So we've got, again, we tell Excel it's a formula, and then we still have the same inputs. So outputs. So 1,400, 1,400,000, and then divided by, and here we want to multiply the labor hours times, and that in Excel that's an asterisk, the labor rate, and that's 2.4. Now, if you are new to Excel, that parenthesis was critical, because what Excel will do, if you didn't put that parenthesis, it'll start just doing it in order that it finds it. So it'll take the outputs, divide it by the number of hours, then take that product and multiply it times the labor rate. Let me show you. So if we took these parentheses off, this would be a mistake, but if we're going to take them off, instead of that 2.4, we end up with 509.95. That's a whole different number. And it's not, you're not actually producing 500 units per labor dollar. You're not even close. So this parenthesis is essential to this one. So that's 2.4. You do the same thing in 2B, similar formula that you have in 2A, except you moved it over into the D column instead of the C column. You're going to do that for all of the different factors that are possible inputs. And then at the end, you're going to calculate a total factor productivity. And so that's outputs divided by all of the inputs. And so to do that would look something like this. Again, we have to tell Excel that it's a formula, and then we go up here and we have outputs divided by, and we're going to need we really need a parenthesis here. Still going to get the labor dollars, we're still going to have this product of labor hours times labor rate. So we've got this times the cost per hour, and then we add, and Excel will do multiplication division first and then adding. That's the hierarchy, just like in algebra. And then we add the material cost plus the equipment cost in dollars. Make sure that's in dollars. Plus, I'm sorry, I'm forgetting my keyboard here, the fixed cost, and then parenthesis at the end, and the total factor productivity is 0.32. Is that possible? Is that reasonable? Yes, all that means is that it costs you more than $1. In fact, pretty close to $3 per every unit that you produce if you're counting all of the inputs. So that's basically how you work this problem. In the second tab, you're going to make some changes as per the instructions, and you'll be making the changes over here in the yellow area. And in one case, you have an incremental cost. That means you add it to what you started with, and so you make the changes here. Then you basically look and say, what would happen to each of these? Labor productivity in terms of units per labor hour. You don't even need to calculate that, because think about it. You have the same outputs, but now I believe you decreased the labor cost or labor hours. And so if you have the same outputs but you decrease the inputs, then the productivity will go up. And so in this particular part of it, all you're doing is say, did it increase, stay the same, or decrease? And so you go through those and answer the questions. And that's hopefully a huge hint, big hint, or as my daughter used to say, a loud hint. Thanks. See you soon.